precipitator. What's a precipitator? What does it do? Okay, it tries to remove dust particles from entering to the air. Okay, so it's like found in the chimney. Okay, so this one is quite easy lah. How the idea how it works is actually not too difficult, right? Whereas if I ask you to explain photocopying machine, that's worse lah. Okay, spray painting a car also quite logical. Okay. Anyway, we talk about the precipitator first. So this one combines questions on heat transfer. So 1A, explain why the hot gases rise. Hot gases rise because it is less dense. Correct. Alright. So you say the gas, don't have to write lah. The gases when heated, okay, volume expands, the mass remains the same, therefore density decreases, and so being less dense it will rise. Okay, so they are asking you heat transfer question. Same with part 2. How does energy pass through the metal pipes by conduction? Same thing. Okay, all this you're supposed to know from the chapter. Okay, now the precipitator. Okay, so we come to the electrostatic part. How does it stop dust and ash from emerging from the chimney? So what happens? So all your hot ash and dust are rising because it's hot. Okay, if you have nothing, it will just go into the atmosphere, cause a lot of pollution and everything, a lot of dust and smoke and so on. Okay, so what do? They have a precipitator. How it works is this. By nature, when the hot ash, is it the hot dust or this, as it rises, is it charged? Yeah. It's not charged, right? So you have to get it charged. So how do you get it charged? Is this. You look very carefully. There is wires over here. Okay, there are wires over here with a negative charge. That means these wires are negative charge. And then there's this thing over here. The plates are positively charged. So when the dust is not charged, you need to get it charged first. How to get it charged is this. Okay, this way. So let's say I draw like that. So this is your wire, and then your dust, this is your dust, which is neutral at first. The dust touches the wire. Okay, and then it gets charged. But how? How? We use a ERO again. Okay, so when this one you want to write down, you can write down here. But you're going to not have a lot of space, so write very small, try to squeeze everything in. So I'll write here, okay, where you can see. So what happens when the dust or ash, which is neutral, touches the negatively charged wire, something happens. This is not electrostatic induction. Why? Why is this not induction?
Because there's contact.
Because there's contact. Okay, and it's not friction either. So it is contact. So when it comes into contact with this negative charge wire, what happens? The dust is neutral. Again, we follow our ERO. So electrons, Jeremiah, are going to move from where to where? The wire to the dust or the dust to the wire?
Wire to the dust.
Wire to the dust. You know why not? Dust, neutral. 0. Wire, negative. Right? Is at a lower potential. So electrons move from the wire to the dust. Okay, so that's your E. Because, why? First or second reason? First or second reason?
Second reason.
Second reason. Because the dust is at a
high potential.
Higher potential, yes. Okay, so the electrons will go over from the wire. Okay, because the dust is a higher potential. So the dust is a higher potential. So when you explain, you already explained the E, electrons moving. Then You have already said R, the reason why they move, because the dust has a higher potential. And then now don't forget the O. The O is, as a result, your dust is
Negatively charged.
the dust becomes negatively charged, correct. Okay, so when you follow this way or my format of answering, you will surely not miss out anything. Okay, you miss out things is not because you don't know. You miss out things because you just didn't know you had to write it. The dust becomes negatively charged. Okay. Now, this is just the first paragraph of the answer. You haven't even said the second part yet, but the second part is easy. Okay, so that is how the dust becomes negatively charged. So it hits, it touches the wire. At first, not charged. Touch the wire, become negatively charged. And then as it rises, this is easy to explain. What happened?
Electrostatics.
Negatively charged, positive plate. So what happened? You get attracted towards the plate because unlike charges attract. Correct. Okay. So the second paragraph to your answer will be then to say that as the negatively charged ash or dust rises, it moves towards the positively charged plates as unlike charges attract. Okay, that's your reason. So as a result, it reduces dust and ash from emerging from the chimney, right? So it's a very long answer. You see, you read, very long, 2 paragraphs. Peng Hong loves this kind of answer. Okay, so but don't have to worry. It's not that difficult, right? You see, you follow the logic to it. It's very simple. Okay, so the first one, how it got charged is by contact, not induction, not friction. It got charged by contact because of potential difference. It got charged. Then after that, it starts move towards the positive plate. Then because of unlike charges attracting, right? Okay. So must the plate be always positively charged? Can the plate be negatively charged? Can. But then you must make sure your wires will be positive. If you go and make the wires wrong, what happens? Everything you repair everything out, even worse. Alright, nothing is collected. Alright, so that is a precipitator, which is quite easy.